All right, here we go. Section 7.8.2. We're talking today about what's called synthetic division. We're going to start by defining. When you divide a polynomial by a linear factor, such as x minus r sub 1, you can use a shortcut method called synthetic division. Synthetic division is simply an abbreviated form of long division. Now, the important part of this definition that we always have to take into consideration is that we must be dividing by a linear factor. Okay? In the form x minus r sub 1, a linear factor would be like if you were dividing by x minus 3 or x minus 7, but not something that would be like x squared minus 2x plus 1. If you're dividing by that, you have to do long division. You cannot do synthetic division. Synthetic division only works when dividing by a linear factor. All right, on this side we have an example. We're dividing 6x cubed plus 11x squared minus 17x minus 30 by x plus 2. That's a linear factor. This can still be done doing long division, which we're going to talk through as a quick review, or it can be done with synthetic division. So let's take a look at both. We'll cover this up for right now, so that we just focus on the long division. X goes into 6x cubed, 6x squared times. And we multiply. 6x squared times x is 6x cubed. 6x squared times 2 is 12x squared. Then we subtract, and we get negative 1x squared. And we bring down the negative 17x. Then we ask how many times does x go into negative 1x squared? Well, it goes in negative 1x times. So negative 1x times x is negative 1x squared. Negative 1x times 2 is negative 2x squared. Then we subtract, and we get negative 15x to bring down the minus 30. Then we ask how many times does x go into negative 15x? And the answer to that is negative 15 times. And then we multiply. Negative 15 times x is negative 15x. Negative 15 times positive 2 is negative 30. And then we subtract, and we see that we get a remainder of 0. And so our final solution to this long division problem is 6x squared minus 1x minus 15. Now, since we're dividing by a linear factor of x plus 2, we could use what's called synthetic division instead of long division. So let's take a look at the synthetic division problem over here. Now, it's already completed for us, so we're just going to talk through it as a first example. Looking up top at our x plus 2 linear factor right here, we don't use the linear factor in a synthetic division problem. What we use is the root. Now remember the root format, x minus r sub 1? Well, the x minus r sub 1 is the root format, and x plus 2 is the linear factor, then really that's x minus negative 2, and the root is negative 2. And we always write the root first, right here, in this little like half box. The next thing we do is we take the coefficients of the polynomial that is being divided, and we write those coefficients out. So for example, the coefficient of this x cubed term is 6. That's why there's a 6 right there. The coefficient of the x squared term is positive 11. That's why there's a positive 11 right there. The coefficient of the x term is negative 17. So there's a negative 17. And then finally the constant is negative 30, and that's why there's a negative 30 right there. Now it's important to remember what we talked about with long division. When we didn't have a certain term, we sometimes had to put like a 0x squared or a 0x in there to hold that place value. You have to do the same thing with synthetic division. In this example, we don't have that issue because we have x cubed, x squared, x constant. So that's good to go. But in some synthetic division problems, when you don't have every term, you're going to have to put that 0 term in there to hold that place so that everything lines up. So keep that in mind. Now that we have this initial setup right here, we are able to start the synthetic division problem. And we start it by bringing down this first number, in this case the 6. Now the general rule for synthetic division is the numbers under this line are being multiplied, and the numbers above the line are being added. So let me talk through the process here. Since we brought down the 6 and it's now under the line right there, we're going to multiply it by our root. So we're going to do negative 2 times 6 to get negative 12. So this is what we did. Negative 2 times 6 equals 12. Now since 12 is above the line, or negative 12 is above the line, we're going to add 11 plus negative 12 equals negative 1. Now negative 1 is below the line, so we're going to multiply it. So negative 2 times negative 1 gives us positive 2. Now we're going to add negative 17 plus 2 gives us negative 15. Now negative 15 is below the line, so we're going to multiply. Negative 2 times negative 15 is positive 30. Positive 30 is above the line, so now we're going to add. Negative 30 plus 30 is 0. 0 ends up being our remainder, and then we work backwards, so to speak. So if 0 is our remainder, right there, remainder, then negative 15 is our x term, it's our constant. It's our constant. Negative 1 is our x term. 6 is our x squared term, and if we kept going back, it would go x cubed, x to the 4th, x to the 5th, and so on. So that's how you know what your final answer is. The 0 is the remainder, the negative 15 is the constant, the negative 1 is the coefficient of the x term, and the 6 is the coefficient of the x squared term. So our final answer is 6x squared minus 1x minus 15, and you can see that that's exactly the same answer as we got when we did the long division. Alright, in our second example here, we're using synthetic division to divide x to the 4th minus 10x squared minus 2x plus 4 by x plus 3. The first thing that I'll point out here is, again, we are dividing by a linear factor. That's what allows us to use synthetic division. If it wasn't a linear factor, we'd have to use long division. The second thing I'll point out is in our polynomial that is being divided. We don't have that together. We have x to the 4th, x squared, x constant. We are missing the x to the 3rd term. So we're going to have to put a 0 in that place when we set up the synthetic division. So let's look at how we would set this up. So we take the root of x plus 3. The root would be negative 3. So we put a negative 3 in that little half box. Now we list out the coefficients of the other polynomial. The coefficient of the x to the 4th term is a 1, so we put 1. We are missing that x to the 3rd term, but we need to hold that place, so we put a 0. The coefficient of the x squared term is negative 10. The coefficient of the x term is negative 2. And then we end with the constant. And it's important to note that if you don't have a constant, you also need to put a 0 to hold that place. This is our initial setup. Now we're ready to actually do the synthetic division. Alright, so the first thing we do is we bring down the 1. And then we multiply. Negative 3 times 1 is negative 3. And we add. 0 plus negative 3 is negative 3. Now we multiply. Negative 3 times negative 3 is positive 9. Now we add. Negative 10 plus 9 is negative 1. Now we multiply. Negative 3 times negative 1 is positive 3. Now we add. Negative 2 plus 3 is positive 1. Now we multiply. Negative 3 times 1 is negative 3. And now we add. 4 plus negative 3 is 1. So now that we finish our synthetic division, what we know is that we have a remainder right there. A remainder of 1. And then we work backwards. This will be our constant, this will be our x term, this will be our x squared term, this will be our x cubed term. So let's write out the answer. We have 1x cubed minus 3x squared minus 1x plus 1 as a constant. And we take our remainder, and just like in long division, we take our remainder and we put it over our linear factor, x plus 1. Oh, excuse me, x plus 3.